So next, we want to study an example of a charged particle moving through a uniform magnetic field. So let's imagine we have a charged particle here. So this is plus q charge, and this is moving in this direction with velocity v. So plus q charge. Okay, so what are these cross marks? Well, basically these cross marks tell you that the B field is like directed inward into the plane or the page. The vector is actually pointing into the plane of this screen, and this dot actually tells you it's actually pointing out of the plane, out of the plane or the page. Okay, so as you can see, our magnetic field is basically the magnitude of the magnetic field, then z hat, that is pointing into the page, and our charged object or charge q is moving along plus x axis. Therefore the velocity v of that charged particle v sub q will be the magnitude of velocity, and the unit vector is just x hat. Then we want to calculate the force that these charged particle feels, which is given by the Lorentz law. F sub b, the force due to a magnetic field, is q v cross b. That's the formula, and if you apply that our cross product rule, you find that you have q times vq times b x hat cross minus z hat. And if you evaluate this cross product, you'll see that you are left with just j hat. Why? You can just apply the right hand rule, and if the velocity is along x-axis and magnetic field is pointing downward, then the right hand rule tells you the force that the charged particle will feel in this magnetic field will point along y-axis plus y-axis. So you have j hat or say y hat. Now since you have this force, you know what will be its motion. At least you might have some ideas. It will be basically a circular path, because at this point the particle will feel force in this direction, and it will move from here to there, and at that point particle will feel force in this direction and it will move here to there. I'm just applying this cross product rule everywhere, and this particle will make a circular path. So it's not a perfect circle, but you get the idea. It will be a circular path with some center, and radius, say radius of the circular path is radius r. Okay, so one thing we know, that if a particle or an object moves in a circular orbit, then it will have a centripetal force, which is F, let me use black color, which is F sub c is mass of the particle m times v squared, the velocity of the particle squared, divided by the radius of that circular path. So next what we can do is that, since the force is basically magnetic force due to its motion through the magnetic field, and this to have a circular orbit it must have this centripetal force, you can equate this. What we can do is F sub b, magnitude of this, and equals to m v squared, or I should just write first Fc, magnitude of centripetal force. Then in the next line we can write up q v sub q, the velocity b equals, well, it's also v sub q, because it's the same particle we're talking about, m times v sub q squared divided by radius r. So from this relation we can find the radius of the circular orbit, which is r equals m v sub q divided by charge of the object times the magnetic field. This is the radius of this circular orbit, and since now we know the radius, next we can find the period of its movement through this circular orbit. The period means that if you start from here, how much time you need to go through one cycle through this path and come back here. That is called one period. We denote it by big T. Period T is basically the circular path twice pi r divided by the velocity v, or v sub q, and we know the value of r from here. Just plug it in here, vq divided by vq, q times b. So velocity vq cancels out. You are left with twice pi times the mass of the object or the charged particle divided by the charge times the magnetic field. Okay, since now we know the period, next we want to find the frequency of that charged object. So frequency f is basically 1 over t. So q times b over twice pi m. This is the frequency of that object moving in that circular orbit. So next what you want is the angular frequency. Angular frequency, or omega, is basically twice pi f. So we are left with charge q times the magnetic field divided by the mass. So this is the angular frequency of that charged particle in this magnetic field.